Hi guys, today's lesson is on molecules and covalent bonding. So we are moving away from ionic compounds now, and we are going to start talking about a different type of compound formed between two nonmetals. So a molecule is made up of two nonmetals, and the nonmetals are joined together by a bond called a covalent bond that actually allows the two nonmetals to share electrons. And this is really different from ionic compounds because if you'll remember, ionic compounds are formed between a metal and a nonmetal. The metal is losing electrons and the nonmetal is gaining electrons. So there's a transfer of electrons going on in an ionic compound. In a covalent compound, you have two nonmetals sharing their electrons. So nobody's giving or taking, they're sharing their electrons. And the bond that's created when they're sharing their electrons is called a covalent bond. So a type of molecule that we are going to start with is called a diatomic molecule. And di means two and atomic means atoms. So these are molecules that are made up of two atoms joined by a covalent bond. The atoms can be two of the same, so two of the same elements, or it can be between atoms of different elements. So if you'll notice in this diagram, I'm showing you two hydrogen atoms coming together, and you'll notice that they're both sharing the one valence electron that they have on their valence shell, and now they both have a complete and stable first shell because there's two electrons on each shell. They didn't give up or take, they are sharing each other's electrons. In the bottom left-hand corner, you're going to see hydrogen being bound with fluorine, and hydrogen and fluorine are sharing their electrons, so now they both have stable valence shells. You'll notice that the hydrogen bonds on the top are between two of the same type of atoms. They're two hydrogen atoms bonded together. And you'll notice that hydrogen and fluorine coming together, those are atoms of different elements coming together, both considered diatomic molecules. Here's a list of diatomic elements that naturally in nature are found as a pair of two of the same type of atoms. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine, they have a tendency to be found in pairs of two stably in nature. They are called Hofbrinkel, and I'm going to write that in the bottom corner here so that you can see it. We use Hofbrinkel, and you'll hear me talk about Hofbrinkel a lot. Hofbrinkel is a mnemonic that we use to remember the elements that actually are found as pairs of two. What's important to note here is if you ever have an H2 molecule in a chemical equation, you have to name it as the element's name with the gas state in it. And so what I mean by this is if you see H2 in a chemical equation, that's not just hydrogen, it's hydrogen gas. So all of these diatomic elements, when they're bonded as two, they're a gas at room temperature, and we do have to indicate that. So you would have to tell me it's hydrogen gas. So H2 is hydrogen gas. O2 is oxygen gas, okay? And you can use Hofbrinkel to remember the elements that are included in them. So how do we name molecular compounds? I actually think that naming molecular compounds or covalent compounds, we use those terms interchangeably, is a lot easier than naming ionic compounds because we use prefixes, and prefixes are words in front of a word that indicate the number of atoms that the compound contains. We do this because elements can form different combinations of molecules depending on how they're sharing their electrons. So carbon and oxygen can form different molecules. For example, CO2 is a combination of carbon and oxygen, and we call it carbon dioxide. But CO is also a combination of carbon and oxygen, but we call it carbon monoxide. And you'll notice the only difference between the two is how many oxygen atoms are in the formula. Carbon dioxide has 2 oxygen atoms, whereas carbon monoxide has 1 oxygen atom. They are very, very different compounds. They are not the same thing. So we use prefixes to decipher which one's which. So here's a list of prefixes that you will be responsible for knowing. Mono means 1, di 2, tri 3, tetra 4, penta 5, hexa 6, and deca 10. Okay, so how do you name a molecular compound? The first thing you're going to do is name the first nonmetal. You are going to use the nonmetal's name, obviously, but you are going to include the prefix based on the number of atoms that the nonmetal has, except if there's only 1 atom. If there's only 1 atom, you are going to exclude the prefix mono for the first nonmetal. Then you're going to name the second nonmetal. And for the second nonmetal, you're going to use the name of the nonmetal, but also the prefix that applies to the number of atoms. And in this case, for the second nonmetal, you are going to include mono in the naming. So mono is never used for the first nonmetal, but it is always used for the second nonmetal. Okay? And then you're going to change the ending of the second nonmetal to IDE. And this might sound really confusing, but we're going to do some practice problems and hopefully it becomes a lot clearer. So let's write the names for the following molecular compounds. Let's do, actually, let me show you them all first. Okay, let's do the first one. We have N2O3. So the way you're going to answer all these problems is the first thing you're going to ask yourself is this an ionic compound or is it a covalent or molecular compound? So you check to see if it's made up of a metal and a nonmetal or 2 nonmetals. Well, I know because of from the periodic table that nitrogen and oxygen are both nonmetals, which means I have to include my prefixes when naming these compounds. So nitrogen has 2 atoms. So 2 is di. So I'm going to write this as di-nitrogen. So the nonmetal name stays the same. You're just including the prefix, which is di. And then oxygen, I see that there's 3 of them. So this is going to be dinitrogen, tri, and then the second nonmetal, you have to change the ending to IDE. So this becomes dinitrogen trioxide. Let's try the next one. So I see that there's 1 sulfur atom, and I know that there's 1 because there is no subscript here. And when there's no subscript, the invisible number 1 exists. So because it's our first nonmetal, I am not going to write mono. I am just going to write sulfur. Okay, and then I go to my second nonmetal. I see that there's 2 atoms, so that means di, and oxygen would become oxide. And actually, I'm going to make this a lowercase. Accidentally. Okay, dioxide. All right, let's try the next one. I see I have 4 carbons and 10 hydrogens. So 4 is tetra, so this is going to be tetracarbon decahydride. Okay. And then lastly, I see that this is still a diatomic molecule. There's still 2 atoms bonded together covalently, but it's the same element, and it is a Hofbrinkel element, which means that it is going to be named as a gas. So this is actually hydrogen gas. Okay. Let's now write the formulas for the following compounds. So we have carbon tetrachloride. So this is really, really easy. You're going to use the prefixes to determine the subscripts in your formula. So carbon has no prefix in front of it, which means there's 1, right? Because it's mono and we don't use mono for our first nonmetal. So that means that there's 1 carbon atom. Then we have tetrachloride. Tetra means 4. Chloride is chlorine, so that means there are 4 chlorines. Now, I don't have to include the 1 on the carbon, so I'm going to get rid of it now. And so this formula becomes CCCl4. Okay? Let's try the next one. Dicarbon, di means 2, so that means there's 2 carbons, C2. Hexahydride, hexa means 6, hydride is hydrogen, so it's going to be H6. Okay? And then oxygen gas, well, I know that's one of my Hofbrinkel elements. That's my diatomic molecule that's always found as 2 atoms, so I'm going to write O2.